Hello, my name is Miles Hawley. I'm a high school senior in San Diego, and the video that you are about to watch are the end stages to a project that I've been working on for over 2 years. Now the parts on this table are all to be made into a project that I like to call the IECR, which stands for Inertial Electrostatic Confinement Reactor, also known as a Fusor. Now essentially what a Fusor is, it's a type of fusion reactor which uses electrostatic fields to confine different elements, specifically deuterium. Now the Fusor first came up in 1964 by the man named Philo Taylor Farnsworth. He invented this along with several other things like the TV. Now we're going to look at the blueprints for this Fusor. Now I have Farnsworth's blueprints and my blueprints to compare. Then we're going to look at the parts that we have, we're going to build it, and then we're going to test it. Now let's look at the blueprints that we have. Now this right here is a 1968 patent from Farnsworth that I have in my project folder just to look at and review and look at the parts that he used. Now essentially it's just a bunch of different pictures talking about the different specs that he used and the different designs that he used and the graphs that he recorded. Now, I ended up making my own blueprints, and this was my original blueprint from when I first thought of this idea. Essentially what it would look like. Now, the idea behind my design was to create a cylinder made of acrylic. Now, kind of like this can. On the top, it would be sealed, and the bottom as well. Now, on the top, there would be a tube leading out to a vacuum pump, which would suck out all the air in the chamber. Additionally, there would be a gauge on the top to measure out how much air is left. On the bottom and on the inside, there would be an inner grid made from tungsten. Leading out and connected to 2 diodes would lead to a transformer which would power the reactor or the Fusor. Now this is a great design and all, but it's not the best that it could be. Instead, I went for a more expensive but better part, and this is conflat flange, which is a special type of vacuum part that is used in laboratories. Now let's look at the parts that we have. Now this is the first part that I ever got. This is called a diffusion pump, and it's a special type of pump which is used after a rotary pump, which is a pump that I have on the table, which we'll look at later. Now this diffusion pump I managed to get out of an Arizona laboratory, and I hope to repurpose soon. Now let's look at the other parts that we have. Now making a fusion reactor is not a cheap thing to do, which is why I luckily got sponsored by someone that I worked with, a company called Treobytes, which basically is a kids technology hub. They develop curriculums for schools, and I did some volunteer work with them, and so they managed to help fund my project. Now the parts that I have on this table are different parts that I've collected over a few years. So when picking up these parts, we actually want to put on gloves, which is what I did, because the oils on our fingers will get into the chamber and ruin the vacuum. And so that's why I put on these gloves. Now the first part that we'll be looking at is this. This is the main part in the reactor. This is a 2.75-inch conflat flange 5-way cross. This is the main chamber, which we'll use. It looks like this. It has 3 rotatable flanges like this one right here, and 2 stationary. It is 5 ways, which means you can have 5 different lines or 5 different operating systems on this, which is very important because if you want the main full-on Fusor, you would need 5 different sections. Now the next part we'll be looking at is going to be our flats. Now because I'm not going to be using deuterium for this reactor, I had to secure 2 different lines with something called flats. This is 2.75-inch conflat blank. Essentially, it's as it says, it's a blank. You just connect it and it seals off the vacuum. I have 2 of these as on the table, this one and this one. Now the next part we'll be looking at is kind of a collection of different parts that all work together. Now this right here is going to start it off. This is our second stage rotary pump, which I talked about earlier. This is going to suck most of the air out of the chamber that we have in order to create a semi-vacuum. Now this right here, this piece right here is going to be connected to this. This is my micron gauge, which is going to read how much air is in that chamber. Now this is going to connect to a series of different parts. Now this was a big problem for me because when I bought the chamber, I wasn't exactly sure how I was going to connect this, which is a 1/2 inch ACME part connection to a conflat flange. So what I ended up doing was I bought this, which I thought would work, would connect to that. Unfortunately, this is a way bigger inner diameter than that, and so I had to find a different parts to connect it. Now what I did to connect this is I bought a series of adapters to connect the different parts. Now this part screws into here, which then connects to this adapter. This adapter screws into this side, and then this right here is a barbed, for a barbed hose. This is for a 1/2 inch for a hose, and this is going to connect into our hose right here, and the other side of that hose will connect to here, which is also barbed, and then this will screw into here. So as you can see, it was kind of a convoluted process as to how to secure this vacuum, but I did manage to in fact secure the vacuum. Now the next part that we'll be looking at is this. Now this is what I was talking about earlier. This is our inner grid. Now the original design was to use these right here. This is tungsten, which I poorly formed into rings, which were wrapped in such a way to form an atom-like shape like this one. So what I did was instead, because this was so bad, I decided that I wanted to use steel wire instead. So this is galvanized steel, which I then formed into this kind of atom-like shape. Now the connection isn't the best here. I had to take a bolt and bring it down this tube, or down this metal piece, and then I took my my rings essentially, and I slid them in and formed them and wrapped them in such a way that it won't come off, and it's formed the shape that I want. And when we go into building this, we may have to adjust the position because of how long this metal piece is. Now, this itself, by itself, is called an electrical feed-through, and it's conflat based, so it has these bolts, and it's bolted into the chamber to secure it. Now, this is the inside, this is where it will go into the chamber, and this is the outside. This is a ceramic piece which helps to protect from any electrical problems, and this right here will be connected by our electrical system. Now our electrical system, or our power source, is going to be this right here. I put some alligator clips on this transformer just for safety purposes. This right here is a neon sign transformer, which outputs 10,000 volts at around 30 milliamps. It's not ideal and will not work for a full fusing reactor. It will simply create plasma, which is what I'm going for here. So it won't, it needs different parts to actually completely fuse. Now this won't be directly used, instead it will be connected to this. This is a variac transformer. Essentially what it does, or what it allows us to do, is this will plug into here. This will allow us to regulate how much electricity can flow into the transformer until we get to the maximum impulse of 120 volts, which would be somewhere around here. This will essentially regulate how much energy is allowed to be put into our chamber. Now, this piece I talked about earlier, the problem with the adapters. On the other side, it allows for a little hole on the inside, which will then be connected to this. This is essentially a conflat tube, which will then be connected into the chamber. This was used, but it is in fairly good condition, so that's why I'll be using it for this reactor. Now over here, this is just for extra safety. This is, some people call it a dead man's pedal. It just allows for, when you push down on the pedal, it allows electrical flow to go into the variac transformer. I also have some safety gloves. These gloves are essentially just rubber gloves rated at, I believe, like 12,000 volts. The next part that we'll be looking at is this. Now, in order to determine what's happening on the inside of the reactor, we need to know what it looks like on the inside. We need to know what's happening, and so that's what this is for. This is a 2.75 inch conflat viewport. It's glass right here, so it's a special type of glass which will hopefully protect us from any radiation. This is going to be connected into the chamber, or onto the chamber. The final parts that we'll be looking at are the bolts and the gaskets. Okay, so these, we'll be looking at the bolts and the gaskets. Now, in order to have a complete seal on the chamber, is if you look right here, there's this little indented ring. Now, that's what these gaskets are for. These gaskets fit into here and then are bolted together to create a complete seal. And so that's what these copper gaskets are for. Additionally, we have our bolts, nuts and bolts. These are used to essentially secure each piece to the chamber and to make sure that there's no rubbing or anything like that. Now, this is essentially the main parts for this reactor. These are all the parts that I'll be using for a demo Fusor, which once again means that it won't actually be fusing anything because we're not using a gas, but it will in fact create plasma. Now let's go into building this reactor. Okay, so now we're going to take our copper gasket and put it on the little indent here, just like that, and it just fits in really nicely. It's a little bit hard because it's rotatable, which means it moves up and down. Now that we have our bolted piece, we're going to put it in here, slide it in best that we can, and make sure that the copper gasket is inside and locked in place. Just like that's our first piece done. I'll secure it in tighter later, but that is essentially what our first part will look like. This is going to connect to a lot of our adapters, which will eventually connect to that. Now we're just going to leave this here and attach that last. Now next what we're going to do is we're actually going to handle it with our main chamber. And instead of working with our rotatable flanges, it's a little bit more difficult. So we're just going to work on our blanks and viewports. So let's start off first with our blanks. One is going to go on this side, the other is going to go on this side. The vacuum part is going to go here, and the electrical is going to go here. This is our blank. It's in this cardboard piece right here. This piece right here. And earlier I cleaned all of these parts with ethanol alcohol to get all the any fingerprints off of it. Okay, once again there's an indent here, and there's also an indent on here, and that's where our copper gasket's going to go. And for ease, I'm going to secure, that's what I say like. Sometimes, let's try not zero, that's not happening. Those are our flanges, our bolts. Turn this up. Plug in our copper gasket, and then take our blank with bolts and lay them on the inside. Then we're going to take our nuts and bolt, secure our blank. Okay, so now basically I've been able to secure our blank to our chamber. next we're going to make our blank, and I've rethought the positioning here, and this will have to go, because of its length, will have to go on one of our side ports and can simply not go on the top. Additionally, that means that our vacuum will go in here, a blank will go here, our viewport will be here, and our electrical will end up being here. So let's put on this blank. So we're going to take our copper gasket and slide it into the little indent here. Make sure that it's in place, and then place our blank on top. So now we've secured 2 of our planks onto our chamber. Next, we'll be putting in our viewport. Grab another copper gasket. Place it here. Unbox our viewport here. Our edge with the indent. Take out some more bolts. Okay, so now we've secured our viewport to our chamber. We are actually almost done. I'm now going to attach our electrical feed through, but before it goes in all the way, I have to make sure that it's centered, essentially. Okay, so I had to make a new grid because the other one just wouldn't fit. So now we're able to secure this one into the new one. I'm going to grab another topper gasket. Place this our little indent, get out some more nuts and bolts. Okay, so now we want to take our electrical feed through, flip it upside down, and put our bolts through. Just like that. And carefully position our piece. Just like that. And then we want to nut in or bolt in our thing. Okay, so our thing is mainly complete. All I have to do is put in our final piece, which is connecting this to here. Real quick, I'm actually going to tighten this up like I did with the rest. So this is our complete chamber. We have a blank, our viewport, our electrical feed through, our vacuum system, another blank, and that's it. And then we have the bottom. So now what I'm going to do is I'm going to use these different adapters to connect this to our vacuum pump. So as you can see, I've kind of cleaned up my workspace so it's easier to see what's going on. There's not a lot of parts around, so it's a lot safer and a lot cleaner. Now what I'm about to show you is an in-depth view of how I'm going to connect the VCO to the 1/2 inch ACME. Now as you can see that these two different connections are in fact completely different. This one's a lot bigger than this one. So I'm going to show you in a short amount of time what I had to do, how I had to connect these with a short timeline, and so that's what I'm about to show you. So let's go look at that. Okay, so now that we have everything kind of in depth right up here, we're going to start the construction here. Now there's a couple different adapters, and we're going to first start off here. This is the 1/2 inch ACME, and I had to buy two separate adapters. The first one is here, this piece right here. I connected it already and it's in there real good, so I don't want to disconnect it. And then connecting to that is another adapter, which is a hose barb, which is going to connect to this tubing. So we now want to slide this in here and tighten it. On here, I additionally threw in some plumber's tape to give it a better fit. Now we can just tighten this up. We need to get it really, really tight because we want a good vacuum. Okay, so just like that. And then this barb is going to connect here. Now additionally, we're also going to clamp it in. So we're going to slide the clamp over the tube and slide the tube down the barb. Now that the tube is now over the barb, we need to take our clamp, hold it, and tighten it with a screwdriver. So I'm now placing the clamp over both the adapter and the tubing, where the tubing touches the adapter. We need to get it really, really tight. Perfect position, and we just need to tighten it. Just like that. So now it's not going to come loose there. Now the next part we want to do here is connect this to this tubing here. And the way that I did that was I bought another adapter, which is right here. Once again, it's a hose barb, and it connects in here, which is a 1/2 inch. And I threw in some plumber's tape to give it a better secure point. And now we want to tighten it again. Once again, we want to get that good vacuum, and so we need to make sure that it's secure. This one's going to be a little bit more difficult. So we're going to tighten this right in here. Just like that. Once again, we're going to use another clamp, just like this, and we're going to slide this over the tubing here, let it go down, and then we're going to take this right here and connect the tubing here. Just want to slide this over again. And the tubing is a 1/2 inch diameter, which is 10 feet long, and is made from vinyl. Slide our clamp over again. We need to loosen it a little bit. Once again, we're putting the clamp in the exact same position we had it on the other one. So that is right where the tubing touches the adapter and putting it right there. Alright, there we go. So we have our clamp in and we have our tubing. And I'm just going to move it over on the back. So that way we do in fact have a secure connection. Now the final part we want to do here is attach our vacuum gauge, and this right here is a 1/4 inch adapter that came with it. This is going to slide into our NPT here, and we're just going to twist it until it connects. Position it correctly. It's a little bit funky to get in, but once you do, it'll slide tighten in. Just want to tighten it all the way. Now we have our adapter right, or our gauge right here. We just turn it on, we hold it. There we go. We hold it, and it turns on, and you can measure in microns, torr, pascals, basically whatever you want in terms of vacuum and pressure relation. So we're going to set it to microns. And that's pretty much it. Right now it's at high pressure because we haven't actually done anything. Now I'm going to zoom back out. Now that you know how it's put together, we're going to zoom out, and I'm going to turn this on and show you the pressure being taken, or the air being taken out. So let's look at that. Alright, I've put everything back into place, and I've also taken out our power supply. So this right here, as I explained earlier, is a neon sine transformer, which puts out around 10,000 volts at 30 milliamps. Coming out of the ground is connected to this black alligator clip, and on the back side, if I can turn it around, it's connecting to a bolt, which is allowing for this entire chamber to be ground. So theoretically, you could touch it, but it's ill-advised because it could arc and you could die. The next part here is going to be our positive. This is where the flow is going to come. It's connecting to our electrical feed-through, which is going into our inner grid, and you can see from the viewport. That is the complete setup of the power supply. I turn the vacuum around, which means the gauge is pointing that way, and so are the other connectors. And now I'm going to turn this on and look at the pressure, or look at the gauge, change views to the gauge. So let's do that. Alright, so this is now a close-up on the electrical system that I was talking about. The alligator clip is clipped onto our feed-through, and on the back side, the ground is now grounding the entire chamber. Now if we come over to the left side of our vacuum, there's a little on button, which is what I'm going to switch, and I'm going to point you towards the chamber to see if we get any reaction. 3, 2, 1. So as you could see, there was a little bit of, well, first of all, it was starting up, and then you could see here that it was being pulled in. That's because the pressure, or the air, is being taken out. So if we look at our gauge here, alright, so basically at this point, I'm going to, well, I've set everything up. I've got our power supply out. As I was talking about earlier, this is our positive lead, which is connecting to here, and this is going to our feed-through. On the back here, we have our negative, which is grounding this entire chamber. Leading here, we have our hose connecting up, and our vacuum gauge, which right now, I just turned it on and then turned it off. It should be reading right now. I had to clean it with alcohol because there was some oil in it, so I'm going to turn it on and we're going to see what happens. So as you can see here on the gauge, it is decreasing. The vacuum is in fact sucking out air, and it should lower to around 600 microns. That's the lowest that I've gotten it so far. So I'm going to let this run for a few minutes, and then we're going to start our power supply and run the Fusor itself. And then hopefully you'll be able to see some plasma. So let's go do that. Wait, hold on. It's on. Thank you all for watching. I hope you enjoyed seeing what it looks like on the inside of a fusor. Now generally, it looks purple, but for some reason when it was recorded, it looks more bluish. But it does in fact look more purple, and that's kind of the color of the plasma that's formed. And for some reason it looked bluish, probably because of part of the camera's system. Now I hope that you learned something new, and I hope to do something more with this, hopefully bringing it to a full-on fusion reactor. Thank you.